Hello everyone and welcome to this video. In this video we're going to talk about the rest of the questions in Unit 9. In this lesson we're talking about upper and lower bound and how to use the degree of accuracy to round or to find the upper and lower bound. Basically the degree of accuracy are or is the word that comes after the word nearest. So basically when they tell you to the nearest one decimal place or to the nearest 100 meter, this is the idea of using the number and then dividing it by 2 and then finding the absolute error and then finding the upper and lower bound. So basically this is the original one. Okay, so that's the original. Let me cover the space down here so I can work. So we have the original one here, 6.3. Now, one decimal place, as we said, one decimal place means what? Very good, means 0.1. We take the 0.1, what do? We divide it by 2. Good, we divide it by 2. So after dividing by 2, I will get what? Very good, I'll get something called the absolute error. Let me put the line of fraction here. So that's the absolute error. So 0.1 divided 2 gives me the absolute error, which is 0.05. 0.05. Now, after getting the absolute error, I'm going to add it and subtract it to the original to get what? To get the upper and lower bound. So as we did here, 6.3 plus minus 0.05, which is the absolute error. And this is the actual value, or how we say the upper and lower bound. This idea is very important. We always divide by 2 because we have upper and lower bound. We always divide by 2, okay? So the whole idea of upper and lower bound is having two things. That's why we take the value and divide it by 2. Now, same idea with the next one, which is 5,800. So here, the upper and lower bound will be what for the first question? It's going to be 6.3 plus 0.05 and 6.3 minus 0.05. Same idea here. This is the original. That's the word after nearest, which is 100 meters. It means we take the 100 and then we divide it by 2. And this will give me what? It will give me the absolute error. It will give me the absolute error. So the absolute error is what? Very good. It's 50. Now I'm going to take the 50, add it, and subtract it from the original. This means 5,800 plus minus 50 meters. Plus 5 minus 50 meters. Okay? Because we always put the absolute error here. Now the next one here, 0.09 kilometers to two decimal places. Two decimal places means what? It means 0.01. Because one decimal place means 0.1, two decimal places 0.01. We take it, we divide it by 2 to find the absolute error, and then we add it and subtract it to the original to find the upper and lower bound. So here 0.01 divided by 2 will be 0.005. So this is the absolute error. It means we add it and subtract it with 0.09. So we write it here, 0.005. Okay. Now, same idea here. We have 8 kilograms to one decimal place. One decimal place is the same as this one. So we're going to take 0.1 divided by 2. It will give me 0.05. And then add it and subtract it to the original. So it means this one will be 8.0 plus minus 0.05. And that's the idea of answering a question like this. I just want to add one thing to the topic because it's not mentioned here. What happens if they tell me that the degree of accuracy is one significant figure? One significant figure. Now, let me write a question for you guys. One of the questions came in the achievements. Let me write a question and I'll answer it in one significant figure, okay? Um, Let me use one of the questions and make it one significant figure. Okay. So one significant figure means what? It means the first number. For example, let's take this question and use one significant figure. Okay. There were 65,000 people at a football match, rounded to the nearest thousand. But I'm not gonna say rounded to the nearest thousand. I'm gonna change it to make it one significant figure because we already covered everything except the significant figure. So I'm gonna remove this and write rounded to the nearest significant figure. Okay, significant figure. I'll write it like this, significant figure. So in the question, you'll have it like this. You'll have the original. They will tell you it's rounded to the nearest significant figure. And then they will tell you to find the upper and lower bound. Now, follow the steps that I tell you now. The first significant figure, for example, they will tell you the first significant figure. The first significant figure, it means the first number here. So first thing you do, let's write the original number here, which is 65,000. Now, the first significant figure is the 6. Always focus on this. The first significant figure here is the 6. So I'm going to write 1 under the 6 like this. And then the rest of the numbers will be all zeros. So I'm going to write 0 instead of this, 0, and then another 0 here, sorry, here. So how many zeros? 1, 2, 3. So the first significant figure, 1, and then the rest will be zeros. This is how you start your answer here. So basically, what do we do next? Next, we're trying to find the absolute error. We're trying to find what? The absolute error. To find the absolute error, what do we do? Very good. We do what? We divide it by 2. We divide it by 2. So we take this number and we divide it by 2, like this. As we said, focus on this question because it's mentioned before in the achievements. I think the number was 800,000 or 800 million, I'm sorry. So, first significant figure, I come to the first number, I put 1 under it. And then the rest will be zeros. And then take this number, divide it by 2 to find the absolute error. This will give me what? This will give me, very good, 5,000. So 10,000 divided 2 will give me 5,000. What is the 5,000? It's the absolute error. It's the absolute error. Now, what do I do with the absolute error? Very good. I'm going to add it and subtract it from the original just to find what? The upper and lower bound. So first, to find the upper bound, what do I do? I'm going to add the 65,000 to the absolute error. So 65,000 plus the absolute error, which is 5,000. So the answer will be what? Very good. It's going to be 70,000. Now, as we said, to find the upper bound, we take the original, add it to the absolute error. And then to find the lower bound, what do we do? So lower bound, very good. We take the original, 65,000, and then we subtract the absolute error from the 65,000. And the answer will be what? Very good. It's going to be 60,000. And this is how you answer a question like this. Focus on the idea and focus on the steps of finding the absolute error. Again, as I said, one significant figure, it means you come to the first number in the original number, you put 1 under it, put the rest as zeros, and then divide it by 2 to find the absolute error. After that, to find the upper bound, add it to the original. To find the lower bound, subtract it from the original, and you will get the answers in the right way. Thank you very much for watching. See you next time.